Hello, this is the third video of a polar coordinates series for OCR Pure Core Further Mathematics, and we will convert coordinates between Cartesian and polar forms. On the diagram we can see a general point P in polar coordinates r theta. If we consider what we already know for trig functions for the right-angled triangle, we know that sine theta equals the opposite over the hypotenuse, which in this case is y over r. Rearranging this gives us y in terms of r and theta. Similarly, for cos theta, we know that this is the adjacent over the hypotenuse, which in this case is x over r, leading to the x equals r cos theta expression. Points A and B have polar coordinates 3 pi by 3 and 5 pi by 4 respectively, and we need to find their Cartesian coordinates. Well, we can write that x equals 3 cos pi by 3, which equals 1.5, and y will equal 3 sine pi by 3, or 3 root 3 over 2. We were to plot this on the Cartesian grid, it would give us a point at about here. This is in the same quadrant we are expecting. If we write that x equals 5 cos 5 pi by 4, that will give us minus 5 over root 2, and y equals 5 sine 5 pi by 4 gives us minus 5 over root 2 as well, and this gives us a point which is about here on the Cartesian grid, again in the quadrant we are expecting. It is really useful if we happen to know the standard trig values, so cos pi by 3, if we know that's a half, and if we know that sine pi by 3 is root 3 over 2, that really speeds up the calculations. So again, cos 5 pi by 4 and sine 5 pi by 4 were both minus 1 over root 2. When we're converting from Cartesian to polar coordinates, using Pythagoras on a right-angled triangle will give us that r equals the square root of x squared plus y squared, and tan theta, using our trig function knowledge on right-angled triangles, will be y over x. You will notice that this is what we use for writing complex numbers in a modulus argument form. Considering the tan graph, you can see that there will always be two values, possibly, for theta, in the range minus pi to pi, so we must take care, and a diagram is often useful to help decide the value that gives the correct quadrant for theta, so we would be checking which quadrant our points were in. We have 2 points A and B with Cartesian coordinates 12, 5 and minus 3, 4. We want to find their polar coordinates. Well, we can write that r equals square root of 12 squared plus 5 squared equal to 13 will equal tan to the minus 1 of 5 over 12, which gives us an answer in radians of 0.395. which we would plot on the line 13 and would be somewhere there. So in the same quadrant, and we're happy with that theta value. Here r would equal the square root of minus 3 squared plus 4 squared equal to 5, and theta would be tan to the minus 1 of minus 4/3. The tan value gives us two options, but we choose the one that lies in the second quadrant. So the two values we considered for theta for point A were 0.395, or that value take away pi. The first quadrant led us to this solution. For the second quadrant, we again would have had two options, and we chose the values that lay in the second quadrant. In the next video, we will find areas enclosed by polar curves.